YouTube, what is up? 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 All right, hello there. Greg from Greg's Tutoring NYC. Hopefully, everybody out there is doing fine. I'm doing pretty good today. Between some sessions here, so I'm going to pop this out. We might go for 40 minutes or something today. I'm going to try to get this done by 6 o'clock. How's everybody doing out there? So at least you guys in New York City have started school. I understand it was a little bit bumpy yesterday with long lines and some confusion and so on. So hopefully that's kind of evened out. So I'm in the middle of, this is part 3 of the grade 7 hardest math problems. So again, the context here is that I'm reviewing some of the New York State questions over the past decade that after all, like 500,000 kids took these, the ones that popped up as the so-called hardest ones. Hey, something random. How you doing? All right, guys. So hopefully that makes sense. So if you go back to some of my previous comments, all those contexts will make sense. Hello, people in the lobby. I see a few people joining in. Please like and subscribe. Come on, guys. We need to get some more subscribers here. Set your notifications as well. I already have hundreds of hours with hundreds of videos, and particularly about the SHSAT, but also other exams and so on or whatever as well. I work hard for you guys. This is all free. On that note, if you go to GregsTutoring.com, GregsTutoringNYC.com/gift, please send me a gift or a tip for doing all this. It just costs me time. It's a lot of energy at any event. I have to buy hardware and other stuff to do this as well. So I'm trying to give back to you guys. Throw me a bone or two, right? This is for everybody's benefit to do kind of stuff like that. I got into Brock Science. Oh, yeah. There you go. So it's going to be a new experience for you guys. All right. So what I'm going to do is going to jump right into this stuff. So the last time, it turns out I made 2 mistakes. So let me bring those up. I already posted about them. I rewatch back my streams, believe it or not, just to make sure I make mistakes. Just for anybody catching this, these are all live. There's no editing at all that I ever do. Almost never is there any editing. Once in a while I do a walk and talk, and I can't stream live, so I'll do that and just basically post it. But basically these are edit free, so it means any mistakes or screw ups or technical difficulties, they manifest themselves on top of here. All right. I also have dyslexia, dyscalculia, and dysgraphia on top of it. So my handwriting's atrocious, and sometimes I can see numbers on the screen, like 12.34, and that's actually not the numbers. So I need you guys to be my eyes and ears or whatever as well on stuff like that. And by the way, it just goes to show you how you can still proceed with when faced with adversity, right? If I have these issues that they're real, and yet I can still tutor you guys successfully in math. So having issues, they're real, but they're not excuses, right? All right, so let me just jump into here. Let's get rid of this here. So one of the last problems we did the last time was problem number 36. So I made 2 mistakes there. One was a slight goof up, which was right here. I said divided by 12, but there's a point right there, so it was 1.2. So I actually end up writing the right thing over here, so there should be a point right there. The second thing I did was I have no idea how or why. Okay, that is wrong right there. Okay, I said it was 1.35 times 43. All right, let me bring that up on the screen. For most of your exams, you're not going to be allowed to use calculators, but for the New York State test, you can. But in any event, let's just do that. So we have 1.35 times 43. Okay, and that should have been 58.05, not 44 point whatever I had there. And when you add up the 35.83, the 43, and the 58.05, you'll get the 136.88. All right. So I also made a second error. Let me find that. And I'd like to try to be authentic with these streams as well. I'm a real person, and I make mistakes as well. So you have to, not beat the crap out of yourself when you guys make errors and so on. It was this one. So this is a weird one. I don't know if I just got too tired or what, but we're trying to add up three numbers. The 17.34. Okay, there's 1 and 9 3/4. Okay, and there's 24 right here. So I talked about adding the 3/4 and the 3/4 and getting 1.5. And then when I actually did the total, I ended up knowing the answer was 43.5. I ended up getting 42.5. So what we want to do is take the 17 3/4, take the 1 and 3/4, and the 24. We're going to add up the whole numbers. We get 42. We're going to add up that. We get 1.5. Okay. So what I did was when I finally did the last total at the end of the last stream, I included this one here, but forgot to include the one for the 3/4 plus the 3/4. I only included the half from that. All right, so that's how we get the 43.5 out of that. Okay, so there you go. I've come clean, and that's the two resolutions to those problems. All right, so we're going to proceed on with some new problems today. Again, if you're catching this on the replay, you can stop the video, try to get the answer yourself, and then see if mine matches. What I like to do too with these problems is I'm less doing this to do problem 1, problem 2, problem 3, than to really get it down to the topics and concepts and numeracy. So we're going to be exploring alternatives when we can. Okay, so that you guys can see not only different ways to do it in case one approach doesn't seem to work with you, but it also acts as a way to double check your answers. All right. So that's kind of what we want. We want different ways. Plus, at the end of the day, this is about concepts and topics. So it's about understanding how problems are set up and the math that's reflecting for them. In the real world, you have to solve problems. In fact, in the unreal world, there's too, but you can solve hypothetical problems as well that may or may not eventually become real. All right? Okay, so we have this here. Let me just make sure we're live again. You can solve hypothetical. Okay, we're live. Please like and subscribe, guys. Let me just make sure YouTube thinks we're good. Yes, YouTube thinks we're okay. I'm going to get rid of this calculator for now because I'm only going to bring it on the screen when we need it. Excuse me for coughing in you guys' ears. Let's see here. So where are we? All right, I got a bunch of tabs flying around here. All right, so we have, basically this is a PEMDAS problem. So we're trying to do the order of operations. That's the strangest M in the world. And we have this kind of double negative thing here, this, and this. So we have to kind of figure that out. So we have a dilemma here, and this is some things we discussed in the previous two things, which is that we have decimal numbers and we have fractions. And sometimes it's easy to do everything as a fraction, and sometimes it's easy to do everything as a decimal. We also have to make note that all the answers are in decimals. So that gives us a little bias that probably we should be converting everything to decimals. So let's do that and see if it works for us. So minus 3/4 is the same as minus 0.75. Okay, and minus 2/5, if we make that into tenths, right, gives us 4/10. So we get minus 4/10 from there too. Right? 2/5. If we multiply this by 2, we get 10. And if we multiply the top by 2, we get 4. Okay? So what we have is minus 0.75 minus 0.4 plus 0.4 plus minus 0.75. So here's what I'm going to do instead of going back and forth. This is kind of one of these things like if you have 1, 2, 6, 3, and 4. I would do something like add the 6 and the 4 first to get 10, because that's a kind of an easy number to work with. And maybe do something else like if the next number was 7, I would add the 7 with the 3 and get 20. And then I get 23 out of those series of numbers. So what I want to do, that same kind of thing here if I can, not only because we have a clock coming against us, because normally when you're taking some of these tests, they're timed, right? So not only are you going to have an issue like that, but accuracy could help as well. Because I'd rather add 7 and 3 than add 7 plus 4 plus 2 plus 6. That kind of a thing, right? So what I notice, I have minus 0.75 here. And I also have minus 0.75 here. So what I'm going to just do is add the both of those. And I can get minus 1.5. To me, I don't know about you guys, that's an easier operation to work with. Okay? And I'm also going to notice I have 0.04 and this minus 0.04. So a minus of a minus is a plus. So this turns out to be plus 0.04 plus 0.04. And that ends up being a plus 0.08 then. And now all we have to do is do the both of these. So we can either do minus 1.5 plus 0.08 or reverse them and make it 0.08 minus 1.5. Okay? Which is going to give us B. All right? So that's one way to have done it. We could have also converted everything into a fraction and at the end brought it back. Okay? So let's kind of explore that. I haven't solved this problem that way, so it could get ugly. So let's explore it and see where it goes. So the first minus 0.75, right? It's minus 3/4. Okay. Let's just collapse the minus minus on the 2/5. So we have plus 2/5. The plus 0.4 is 4/10. And the plus minus 3/4 is minus 3/4. Now we can get common denominators between the 4, the 5, and the 10. We can also notice that this collapses to 2/5 back again. So that means we only need to work out the common denominators between the 4ths and the 5ths. So in that case, it would be 20s, right? The least common denominator would end up being 20 if we actually sort it out. 10's no good, so the smallest number that 5 and 4 both go into would be the 20. So we're going to convert the 4 fractions to 20ths. So 3/4, right? We're going to multiply the numerator by 5, so we get minus 15. Okay, which means this is also going to be minus 15/20. Okay, 2/5, we're going to multiply by 4, so this is 8. So this is plus. The next one's plus again. And that's what we got going on there. Okay. So let me just double check that. We have minus 3/4 minus 2/5, so plus 2/5, plus 4/10, which is the same as plus 2/5, and then plus a minus 3/4. So let me make sure I mapped all the 20ths correctly. Times 5, we get that one's good. Times 4, that one's good. Times 4 again, that one's good. And then times 5, that one's good. So what we have is minus 15 twice. So we have minus 30. And we have 8 plus 8 is 16. And that's going to be over 20. Okay, and that's equal to 14 over 20. And we notice again all the answers are in decimal. So, but we also notice we can simplify this. And 14 20ths is 7/10. And of course, since 30 was larger in absolute value, this is minus 14, and this is minus 7 as well. All right, so we end up getting the same answer by using fractions. To me personally, the fractions is more error prone, but it's a double check, and if you have infinite time, this is your alternate way of doing it, just to make sure you kind of really did it right. Now, if you have a complete misunderstanding of PEMDAS, and you didn't realize like the minus minus ended up being a plus, then you're not going to get the right answer no matter which way you do it. All right, so be careful with your order of operation rules on top of everything. So a lot of these questions in a lot of tests are going to get messed up because of the double negative, or even sometimes just a plain old negative. So you guys should watch out with that. Right, let me just make sure the stream is okay. Yep, we're good. Again, please like and subscribe. Set your notifications so when I do more of these, I'm going to finish maybe 3 or 4 more of these for grade 7 and then start on the grade 8 ones. I already did grade 3, grade 4, grade 5, and grade 6. Anybody taking a high school admissions test, you should probably really start from my grade 6 ones. If they're too easy for you, then you can just skip through the stream, replay the stream from the beginning and start each problem. And if it looks too easy, just go to the next one. And you can get through the whole stream in 5 minutes that way. If your proficiency is higher than that. There's always gotchas though, so that's something you guys should always be looking out for. All right, so that's the end of that problem. Again, if anybody has any questions, I see a few people in the lobby. Please ask them. Okay, so I normally like these kind of problems that have kind of these bullet things. For some reason, they tend to simplify kind of the way I'm going to solve it. It's almost like they're giving me space to kind of proceed through it. Not always. Sometimes these turn out to be super hard, complicated problems. So, but I kind of like, because if you notice, as I rip through a word problem, I break it into pieces anyway. So this is kind of physically breaking it into pieces for me. And for the way my style of approaching problems, which I suggest students use, because I think it works. I just think these bullets are really helpful. So 2 people opened a savings account with a deposit of $100. Okay. Lahana earned 2.5% simple interest per year. So simple interest, there's compounded interest, which means it keeps adding on. Okay. So if I had $100 and the compounded interest was 3, I now have 103, and the next year the 3% is on top of the 103. Okay, simple interest is just, it's per year. If there's $100, the simple interest is computed as 2.5%, and percent means over 100. So we're going to multiply that by 100. Why am I multiplying it by 100? Because that's the amount of the deposit. That's how much was already in the bank. These hundreds cancel out, and that means per year the account gets $2.5. Okay? Nothing accumulates in any other way. Okay? The deposit is still there. So in 3 years and 5 years, it's still only getting $2.50 a year. Okay? Okay. Marty earned 2%. So we're going to do it that same way. 2% means percent means over 100. So we're going to multiply that by 100. Okay, the hundreds cancel out, and we get $2. So for Marty, his account, he gets $2 in interest per year. And then it says neither of them made additional deposits or withdrawals. So that means the original deposit of $100, it doesn't change. Now, I don't like the way this question is worded, and this is the actual question that was on this New York State test. What it really needs to say is nobody made any additional deposits or withdrawals. You know, I could have walked up and said, hey, Monty, here's $100 more, right? So it's misleading because then we don't know anything. So what we have to do is sometimes make assumptions about these problems and then just kind of go with it, okay? So we have so far, we have a given, there's $100 in the account. We have another given that it's 2.5 for Liana and 2% for Marty, which means Liana gets $2.50 a year and Marty gets $2 a year, okay? How much more did Liana receive in interest than Marty after 3 years? So after 3 years, she got $7.50 because it's 250 plus 250 plus 250. And Marty got 2 plus 2 plus 2, so he got 6. So what you have to do is subtract the two of those. That's all this is asking us to do. So the answer here would be B. All right? So this one's a pretty straightforward one. Interestingly enough, kids got this wrong. So either they forgot to do the multiplication by 3, or they added the numbers back into the 100 somehow. So they may have done 100, and then like I got 100, for Marty got 102, and then did 2% of 102, and then added that in, whatever that was, they got 2% of whatever that was, like 104 or something. And somehow they ended up getting like $5. Or probably what they ended up doing is, because the numbers don't match, the A, B, C, D is too widely distributed for something like that. They probably ended up getting like $3.50 and was like, whoa, the answer has to be 5 then. I don't know how, but the answer is probably 5. And they did the interest incorrectly is really what it came down to. Also, for some kids who did A, because this is a word problem, it's getting, because of the bullets and so on, if you're not into there. All right, bro. Very good. Glad I could help you guys. So anybody catching this chat on the replay and so on, these are some kids I did live streams with last year. Some of them had their own tutors. Some of them did it solo. But I'm really, really proud of you guys who got into specialized high schools in New York City. I'm actually doing these videos for everybody in the whole country, so I'm not really making these New York City centric, even though I'm using the New York State test. This applies to all 7th graders to what I'm doing right now. However, these are kind of prerequisite and requisite kind of questions for somebody taking a more advanced test for high school admissions. Because if you can't get these problems, you're not going to get the questions on the actual high school admissions test correct either, okay? So these are the prerequisite to give you the heads up. And remember, that's one reason why we're exploring the concepts and the topics and the numeracy as well, because you're going to get very much harder questions on these other kind of things, these other standardized tests or high school admission tests, and you need to know what to do if you're just, you have to pull out of something. You know, you can't make it up, you can't go with your gut, and you don't want to pull a rabbit out of a hat either. You want to do this smartly. So even if you never saw a problem before, be able to pull from all the different parts of your knowledge base in your brain and in your critical thinking, how can I rip this problem apart, build it back together to make sense, okay? That's really what we're doing here. So it's good to see these guys got into their schools and are happy. New York City started school yesterday, so some of these kids are going to some of these schools starting from yesterday, sorry. And with the pandemic, New York City schools were basically closed for the most part. And I'll talk about New York City public schools here. Some other schools were open. All right, so number 8. And if anybody has any questions about the problems I'm covering here, please give a holler, post something about it. So I'm going to go about another 20 more minutes. So I'm going to figure that might be 3 or 4 more questions, and then we'll call it a day. I'm going to try to cut out of here like maybe 5 minutes to 6. So it's 5:35. We have, what, 20 minutes then? Yeah, let's try to do 3 or 4 more problems. So Addison wants to ride her bicycle more than 80 miles this week. End of sentence. So I always put this thing here. What I'm trying to do is take little bite-sized pieces of the word problem and just make sense of it and then build it up as I go through each sentence that way. And within each sentence, if there's a phrase, I'm going to do the same thing. And I'm just going to keep building up my understanding. And I'm going to ask myself questions. So how far does Addison want to go? At least 80 miles, right? This week, in 7 days. She has already ridden a bicycle 18 miles. Okay, so whoops. Let me fix that for a second. She already rode 18 miles. So in my head, I'm figuring this 18 and this 80 is somehow involved. And it seems to me she needs to go 62 more still. Okay, I don't know where the question's going here. I'm just trying to do this to understand it. But it seems to me that 62 plus 18 is 80. And she wants to do more than 80. So she has to still go more than 62 miles. Okay, which inequality? What's an inequality? These four things here, they're all inequalities. Okay, an equation like A equals 5 plus 2. Okay, this is an equation because it's equal. In an inequality, it's basically an unequal equation where we might have A is less than 5 plus Z or something like that. Okay, so that's what they're talking about when they use this word. This is a technical math term. Okay, this has nothing to do with inequity or social injustice or something like that. This is a math technical term. Which inequality could be used to determine the mean number? So we have another technical term here. This is the same as average. The mean and the average are the same word. Arithmetic mean, this means. There's an implicit word here, arithmetic. So the because it turns out there's other kinds of averaging. So the arithmetic mean is the one you normally know about, which is to take, it's the sum of the numbers. Over the number of numbers. Right, so if I have 2 and 4, I'm going to do 2 plus 4 is 6. And the number of numbers here, there's 2 numbers here, I'm going to divide it by 2 and get 3. Okay, so that's the mean, the arithmetic mean, or the average, right? That's what they're talking about there. So which inequality could be used to determine the mean number of miles, M, she would need to ride a bicycle for the remaining 6 days to achieve her goal? All right? So I don't see my mention of 62 in any of the answers. However, I think it's still important because we're trying to conceptually understand what the heck is even going on here, right? So that's important to do too. So what we need to do is basically, if we put this in English, it's going to be the 6 days plus the day ridden already. The 1 day, I'm going to put already rode, right? Because that it has to be greater than the 80. Okay, we know the day she already rode is the 18. Right? So the one that actually matches that turns out to be C. And if we look through it, it says M is the average number of miles per day, right? So if we actually go now and look at it to kind of double check it just by doing kind of reverse analysis, 6 times the average number of days is going to be the total number of miles she rode over those 6 days then. In other words, if we can get the average of them, then 6 times that is the total number of miles she rode over those 6 days. The 18 is the last day that they told us we know for certain she did. Okay, and the sum of those, which is the total number of miles she rode for the week, needs to be greater than 80. All right, so that's making sense there. Again, a lot of kids got the question wrong. All right, so the next problem is a doozy. We haven't kind of met into some of these, but I personally like to look at illustrations first before words. The only gotcha with that is if you notice there's some words, then the two illustrations, and then some more words. So whatever you do, I find even for kids who don't do that, they kind of read these initial words right here in this paragraph here. And once they get to the illustration, they kind of throw those away. So no matter how you slice it, make sure that you're still processing the beginning of that. And normally, the beginning of that doesn't really tell you mathy things. It's just trying to kind of set up the problem. And yet, there's important information in that setup. Okay, this is true of the ELA too. Like you might have a reading passage with a little abstract at the top. That abstract is as much as part of the passage as every part of the passage. Same with illustrations in a passage. They're part of the story that you're trying to read and comprehend. So we're going to do the same thing here. So I like to look at the illustration first. So I'm going to look at this illustration first and then look at the second one. Because I just try to want to understand it for what it is. I don't know what the question is, but in the back of my mind, I'm trying to guess what the question is. And with practice, you can do this about 50-50 and actually eventually guess what they're probably going to ask you. All right, so all of you, first of all, should be familiar with what this is. So first of all, let's look at the title. Before the sign installation. What sign? We don't know yet. We don't know. Then the speed, miles per hour. Okay, so if we notice it goes from 20 to 40, okay, which is not great speeds. So this is probably not a person walking. Could it be a car? Maybe a car, right? Cars normally go more than 40 miles per hour though. But if it's, say, on a city street, you're normally not allowed to go at a faster speed there. So maybe there's a sign installed at a certain intersection to slow down or something. And this could be a digital sign too, we don't know. And what these X's represent is, it doesn't really tell us that, but if it's cars, it means this one here means one car went at 20 miles per hour. Over here, this means two cars went at 35 miles per hour. Okay, so we have some sort of distribution there. Let's see what we have. We have 1, 2, 4, 6, 7, 8, 9, 10. We have 12 X's on the first things, which for now we're just going to assume are cars. And then the next one is now after. So we have a before and after scenario. So it turns out that it looks like the minimum speed stayed the same. And what? Let's see, 1, 2, 4, 5, 6, 7, 8, 9. Yeah, there's still 12 X's. So it's the same number of things that happened, which may or may not turn out to be important. And it turns out that the max speed is now smaller, right? The max speed on this one turned out to be the 40 because there was an X over it. Okay? So I'm kind of getting a feeling that they're looking for what's called points of center. Points of center are range. Mean. So we're taking a slight sidebar on this. I'm just trying to give you a heads up what you should be kind of thinking about as you look at these kind of problems. Median. That's supposed to say MED. My handwriting's atrocious. Min. And max. So the min on both of these are 20. The max on the first one is 40, and the max on the second one is 35. Even though two cars, we're assuming it's cars still, even though two cars were at 35, the max speed a car went was 35 miles per hour. The range is the difference between the two of those. So the range for this one, I'm just going to say R here. I'm not talking about radius. We can have 35 minus 20. Okay, and that's going to equal 15. And up here, it's going to be 40 minus 20. So up here, it's going to be 20. So depending on what kind of analysis you're doing, you can use kind of different numbers to do various computations or make decisions. So apparently there's a road sign. Again, if we're assuming this is cars, and they're trying to do some analysis before and after, they probably put up a sign saying no speeding, or max miles per hour is 30 or something like that, all right? Okay, so that gives us min and max. Okay, range. Okay, the mean is when we add up all the numbers and then divide by the number of numbers. So before I said there were 12 numbers. So on the second one, if we take 20 plus 22, right, this is 22, plus 25, 25, 25, 25, plus 28, plus 30, 30, 30, plus 35, plus 35. If we add that up and divide by 12, we get the mean. On the first one, if we take 20 plus 24 plus 25 plus 25 plus 25 plus 25 plus 30 plus 30 plus 35 plus 35 plus 38 plus 40 and divide that by 12, we get the mean for that. So we can see certain computations are faster than the others. Like getting the range of the second thing, it's just 35 minus 20 is 15. You can almost do that in your head. But to get the average, both of these is a kind of involved process that's probably error prone, even with a calculator. All right. And the median is the middle number of some of these. All right. So let me just get rid of this here. So what we want to do with the median is to order the numbers and then pick the middle number. If there's no middle number, we need to take the average of the two. So basically, for the second one, we have 20. And we could just do these in order because they're there. Okay, comma, 22, comma, and then I'll write 25 4 times, comma, 25, and so on. Okay, and let's say I wrote out the full list, then let me say the last number was 99. What we just need to do is cross off the last and the first, the last and the first. Oh, 25 was the middle number. Okay? So that turns out that's the median. All right? You guys should know that, but it turns out a lot of you don't. You may have gone to a sucky middle school, or you learned this a couple of years ago and it was never taught again in your school. So that's kind of a gotcha. In fact, that's a gotcha even with something like range. A lot of you guys kind of learned this a couple of years ago. Often you may have learned it like in a June when the teacher was just trying to catch up, and you was whizzed right past because it was thought, oh, this isn't hard, and it just went out of your memory. So it's that kind of a thing. Now, if I get rid of the 99, I would get rid of this number, and now I'm stuck with the 22 and the 25. And that's the point we would take the average. So that we would add them up, we get 47, and divide by 2, which is 23.5. Okay, so that's what we have to do for something like here. All right, so let me erase a lot of what's going on here so that we can actually get to now what the problem is about. So we did an analysis of what the two illustrations were about. We took a sidebar to try to explore all the points of center. We don't know what they're going to ask here. They may not even ask anything I'm talking about. I just go on sidebars in some of these conversations. Most likely they are, because this is kind of the way some of these questions go. You can kind of start seeing patterns and get used to what they're probably going to end up asking. All right, so that's kind of where we're going there. And by the way, this is probably going to be the last question, because to answer this is going to be another 5 minutes for sure. And if nothing else, if you were not proficient in these points of center kind of things, now you will be. All right, so we beat this to death in a way. So an electronic sign shows the speed of motorists was installed on a road. The line plots below, and that's what this That's what this whole before installation and after installation, each of those is called the line plot. Okay, it's basically analogous to a histogram, except it's not a shaded thing. Instead of the shaded thing, there's the X's. All right, so that's called the line plot. And again, it means this in the first one, it means there's 4 25s and 2 35s and so on. All right, it doesn't mean there's just you count the X's and do something with them. Okay, normally it's deeper than that. So those are the two signs. Let me shrink this down because we're going to have to somehow get the question on here as well at some point. So there was really no math in this beginning thing, but it gave us the heads up that it was about cars and their speed and that some signs were installed on the road. All right, so let me try to get this big enough so that we can get enough on the screen here. Okay, let me just make sure it's showing on your guys' screen. All right, I believe it is. Okay, then it says, based on these data, which data? The data in the plots. Okay, which statement is true about the speeds of the motors after the sign was installed, right? So what's true after the sign was installed? So basically what we need to do is compare and contrast the two sets of data. All right, so what I'm going to do is, let me just split this. I'm going to call this A, which is before, and B, which is after. Okay, now what we have is, within each answer choice, if you look at it, it's the mean speed and the range of the speed. The median speed and the range of the speed. The median speed of the motors decreased and something. Okay? And the median speed increased and. Okay? If you notice, the last two have the word increase and decreased here. And this one is at the end. Because this says the mean speed and whatever decreased. So for A, the mean speed decreased and the range decreased. So as I said before, range is normally one of the fastest ones to pick out. So the range here was 40 minus 20, which is 20. Okay, and the range here was 35 minus 20. So that's 15. So whichever one has false information about the range, we could just remove that. So A says the range of the speed decreased. So is that true after the sign was installed? Yes. It went from 20 to 15. So far, A is in the game. Okay, B, the median speed and the range of the motorist increased. Well, the range didn't increase, so therefore B is out. Okay, we're not looking at the median speed right now. We're taking the simplest calculation we can get, which is the range, and just seeing which ones kick out. C says the mean speed decreased and the range increased. The range didn't increase. So C is out. Okay? And D says the median speed increased and the range decreased. So A and D are both in. So now what we're stuck with, we need to compare, is the mean speed, whether that increased or decreased, and the median speed, whether that increased or decreased. Okay? So as I said before, both of those are kind of involved computations. But it seems to me it's easier to figure out the median first. And if we need to, then actually do the mean. So there's a lot of computations there. So this is kind of easy peasy if we do what I did before. We're going to take the smallest number, the largest number. The smallest number, the largest number. One of the smallest numbers, one of the largest numbers. One of the smallest numbers, one of the largest numbers. One of the smallest numbers, one of the largest numbers. And when I say one of the, it's the next smallest and the next largest. So now what we're stuck with is two numbers. There's no middle number. So the answer is going to be between them, right? If this is 28 here. then the middle is right there between those two tick marks. Okay? And that's going to be what? 26.5? Did I do that right? 28, yeah, 1.5. Okay, so the median of this one is 26.5. So let's do it for the top one. So because it's 12, we know we're going to get two middle numbers. So we're going to take the next smallest number and the next largest number. The next smallest number and the next largest number. The next smallest number and the next largest number. The next smallest number and the next largest number. The next smallest number and the next largest number. And we're stuck with these two. We have 25 to that, so we know the midpoint is going to be here, which is 27.5. Okay, so then it says the median of the motorist increased, but the median went from 27.5 to 26.5. So D is false if we did all the computations right. Okay, so to actually prove the mean, you're going to have to add up all the numbers and divide by 12. Okay, probably a safe bet that if you do the crisscrosses a second way, that's going to be faster. In other words, if I went and did this, and 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 this, I'm still going to get to 26.5. The same here if I do that, that. Just double check the median. That's going to be a faster double check than actually doing the mean. If you have infinite time, actually go do the mean. But it's clear at this point that the answer is A, because you definitely ruled out B and C, and when we did the median, that D kicks out. So if you want to, as an exercise for yourself, to prove to yourself that the answer is actually A, actually go and add up all the numbers for A, for this part here, and divide it by 12, and add up the numbers here and divide that by 12, and it says the mean speed decreased. So that means if the mean turns out to be here to be like, I'm going to say 30, and then it's 29 here. I'm just making up numbers here. I didn't do the computation. Then that would honor that. Okay. All right. All right. Does anybody have any remaining questions? Because we're gonna peace out now at this point. Remember to smash the like button. Please subscribe. I'm Greg from Greg's Tutoring NYC. You can contact me at GregsTutoringNYC@gmail.com. I'm a tutor in New York City. I can tutor anybody anywhere, though, because of Zoom and so on. And obviously, I'm doing this through the live stream. I specialize in high school admission tests. This is kind of precursor information to that, but it's also good for its own right. I think younger students don't often get an opportunity to have somebody mentoring them in this kind of manner, which is why I did grade 3, grade 4, grade 5, and grade 6. It also gives them the progression to go through. And I want to actually explore that option a little further on this channel as well. In the event, if you need a tutor, I'm your guy, GregsTutoringNYC@gmail.com. Hopefully everybody's having a great day, and peace out.